In this lesson 7.5, we are going to learn partial fraction to solve integrals. So partial fraction is very useful when we have some problems, m of x over n of x. When we solve some problems involving fraction, we might be able to use partial fraction. Before I go over the partial fraction method, let's have a look at the warm-up problem here. So given 1 over x squared minus 2x minus 3 equals a over x plus 1 plus b over x plus 3. So one fraction, how do we split this one fraction into two? So how do we solve for the constant a and b? So in this case, we realize the common denominator, which is x plus 1 and x minus 3. So we multiply everything by the least common denominator. The left side will be 1. And the right side will be a times x minus 3 plus b times x plus 1. Because this equation works for all x values, for any given x values, this equation left and right are always equal to each other. So we are going to set x equals 3. If we plug x equals 3 in, so 1 equals a times 0 plus b times 4. So this gives us b equals 1 over 4. And also, let's set x equals negative 1. So 1 equals a times negative 4 plus b times 0. So this gives us a equals negative 1/4. So this is how we solve the two constants here. Based on this technique, we are going to use this to solve integrations. So the definition for any type of problem, integration n over m dx, this is what we call rational function. Sometimes we could use this technique to split this function into two simpler ones. So based on the warm-up problem, this will be equal to a over x plus 1. So it's negative 1/4 over x plus 1 dx plus b, which is 1/4 over x minus 3 dx. So the first one is negative 1/4 integration 1 over x plus 1 dx plus 1/4 integration 1 over x minus 3 dx, and each of them give us our n of x. So our n x plus 1 plus 1/4, our n x minus 3 plus c. Sometimes we can use a property to combine these two. So it's 1/4 our n x minus 3 over x plus 1 plus c. So this whole process, which we call partial fraction, because we split this fraction into two small parts. Let's have a look at two different types of problems. Type 1. So for improper functions. So improper means the numerator power is higher than the denominator. So n is greater than m. The numerator is greater than the denominator. In this case, how do we integrate it? So first, we have to use long division. So long division, to simplify it, so x squared minus 4x minus 5 divided by the denominator x minus 3. So we have x squared minus 3x to the subtraction, give us negative x minus 5. Minus 1 here, negative x plus 3 to the subtraction, we get negative 8. So that's our remainder. So this problem, after we do the long division, the problem will be equal to x minus 1 plus negative 8 over x minus 3 dx. So this will be x minus 1 dx plus or minus integration 8 over x minus 3 dx. This is x squared over 2 minus x plus minus 8 our n x minus 3 plus c. So for this type of problem, if the numerator power is higher than the denominator, we have to use long division first to simplify it, and then we take the antiderivative. The second type, for proper fraction, if the numerator degree is less than the denominator. So this one, if the power is equal, we can also use the long division tool. If the numerator power is less than the denominator, we can directly split this into two simple functions. So x plus 5 over x plus 2, x minus 1 equals x plus 2a plus b over x minus 1. Next, we just need to solve for ab. Same thing. We multiply everything by the least common denominator. So x minus 1 plus b, x plus 2. We multiply everything by the least common denominator. So we set x equals 1, 6 equals b times 3, so b equals 2, and x equals negative 2, give us 3 equals a times negative 3, so a equals negative 1. So the problem, this is first step. Second step, the integration will be negative 1 over x plus 2 plus 2 over x minus 1 dx. This gives us negative Ln x plus 2 plus 2 Ln x minus 1 plus constant c. And sometimes for multiple choice, you have to be able to simplify this. So we can move these two inside. So it's Ln x minus 1 squared divided by x plus 2 plus constant c. Okay, similarly for the second problem, you have to factor the denominator, which is 2x plus 3 and 4x plus 1. So everybody, you can try this one yourself and compare your answer with mine.